So let's try a whole bunch of these math problems here that I just made up. And for all of them, all we want is the domain. Now here I propose, these are the things that we want to be aware of. We do not want to divide by 0, and we don't want to square root negatives. These are two rules that you should keep in mind. For instance, looking at this first problem right here, we have this function x cubed minus 5. So for that problem there, notice that you cannot divide by 0 here because there's no denominator. Also, there's no square root involved here. So what we can say for this first problem is that the domain is going to be all real numbers. You see, the domain refers to all the x values that you and I have permission to use. I can plug in any number in the whole wide world right here. It can be positive, it can be negative, it can be 0. There's nothing dangerous about this one because this equation will never divide by 0 and you'll never be square rooting any negatives. So let's learn from the ones that actually do give us something to talk about. For instance, this one here, this brand new equation. So here, notice that you could possibly divide by 0 because if I take the denominator and if I set it equal to 0 and solve, notice that that number is bad. Because if I take -4 and plug it in there, it's going to be -4 plus 4, which is 0. And it would be -7 divided by 0, and that's no bueno. So for this problem here, my domain is going to be every number in the whole wide world except -4. So here's one thing I like to do. Pretend this is a number line. And what's going to happen is I can utilize the numbers that are before -4 and the numbers that are after -4 because it's only -4 itself that's bad. Because if I plug it in there, again, I'm dividing by 0. So this is just a little cartoon. The domain itself would be this. Yes, look. The domain itself would be like this. Let's go from left to right. So this goes to the left forever. So I'm coming at it from -infinity, and I have to pause at -4. Like this. Now, I'm going to continue. I'm going to jump over -4 because it's bad, and I'm going to go this ways forever. And I'm going to unite these two intervals. You see, this describes the numbers here, and this describes the numbers there. And the fact that we sort of break it up at -4 just means that we're skipping -4 itself. So this is the answer to this one. This is the answer to that one. And just by the way, if you were to graph this on Desmos, the graph of this one would look something like this. And notice that this graph is continuous. There are no interruptions of any kind. And that's why it's all real numbers. Whereas the graph for this one here, it'll probably look something like this. 1, 2, 3, 4. Let me go like that. Let me go like this. Roughly speaking, the graph would look something like that. It'll have a couple of pieces. But the point is that the graph is smooth, except at -4. There will be a vertical asymptote because -4 causes problems. So let's just keep going here, and then you'll have a better idea of what they mean by domain. So let's see. How about this one here? So notice in this one, we have a top and a bottom, the numerator and the denominator. However, in the numerator, there's nothing dangerous there because there's no square root in the top. In the bottom, however, it can be dangerous because you could possibly divide by 0. This should tell us that x cannot be +8. This is telling us that x cannot equal -5 because if you put -5 there, it's bad. If you put 8 there, it's bad. Notice that 8 is okay here and it's okay there, but 8 is bad there. So as long as a number is bad in any one location, overall, it would be bad, bad, bad. So for this problem, here's my number line. Let me make a cut at -5 and let me make a cut at +8 because these are the two numbers that I am about to kick out of the party. And I kick them out by opening them and including everyone except for them. And now from this little picture, I can go directly into my answer. Let's just pretend that D stands for the domain. Now let me go from left all the way to right. So let me describe this piece here on the left that goes from negative infinity, and then we pause at -5. Okay? And then I resume from -5 all the way to +8. And then I skip +8, and then I resume from 8 to the right forever. Now, of course, just put union, union, unions. So we put these little symbols to unite intervals together. And by the way, it's always parentheses around the infinities. Around regular numbers, sometimes it's a parenthesis, sometimes it's a bracket. I'm sure we'll encounter this as we go along. How about this one up here?